Good day everyone. Welcome to Engineering Data Analysis. This is Christian Talena together with Dominic Suarez, a BSc student under our instructor, Engineer Mary Grace Bacuran. So here's our table of contents. We have chapter 7 entitled Statistical Interval, and we have subtopic of Confidence Interval Single Sample. We have chapter 8, a topic of test of hypothesis and the subtopic of hypothesis testing. Chapter 9, statistical inference of two sample, and having a subtopic of inference on the difference in means of two normal distribution. Variance is unknown. We have chapter 10, simple linear regression and correlation, and having two subtopics which are empirical models and correlation. And the last topic is the chapter 12. The topic is the design analysis of single factor experiment. The subtopic of completely randomized single factor experiment. So let's start with chapter 7 titled Statistical Intervals and the subtopic of Confidence Interval Single Sample. Statistical intervals. It represents an uncertainty that exists in the data because we work with samples that are obtained from a larger population or process. So ang statistical interval ay kapag ang number of sample ay tumataas, napapansin natin na bumababa ang length of confidence interval. The next slide is the confidence interval and its definition. Confidence interval measures the degree of uncertainty or certainty in the sampling method. They can take any number of probability limits, with the most common being a 95% or 99% confidence level. Confidence intervals are conducted using statistical methods such as t-test. We have a formula for the confidence interval where confidence interval is equals to sample mean, adding and subtracting the confidence level value multiplied by sample standard deviation over square root of sample size. Confidence interval single sample. Suppose that x sub 1, x sub 2, and x sub n, where n is a random sample from a normal distribution with a known mean u, mu, and the known variance sigma squared. We have so meron tayong formula for the single sample where z is equals to x bar minus mu over sigma over square root of n, where sigma is the population is widespread or has a larger sample is required. The endpoints or bounds L and U are called the lower and upper confidence limit bounds respectively, and 1 minus alpha is called the confidence coefficient, where mu is greater or equal to the lower confidence limits and less than or equal to the upper confidence limits. So meron tayong table na the most common used critical values are the following. So meron tayong tinatawag na confidence coefficient. So yung mga common is 99%, 95%, and 90%. And we have critical value, which is sa 99%, we have a critical value of 2.575. For the 95%, we have a critical value of 1.960, and the 90% we have the critical value of 1.645. So ang critical value natin is pwede siya magiging positive and negative. So makikita natin yan dito sa may illustration. So next, for the better understanding for this lesson, we have a sample problem. Descriptive statistic on variables measured in a sample of AN is equal to 3,534 participants attending the 7th examination of the offspring in the Framingham Heart Study are shown below. So dito sa may table, magfo-focus lang tayo sa may systolic blood pressure. We have N is equals to 3,534 participants, and we have a sample mean is equals to 127.3, and the standard deviation is 19. So mga nakuha natin na given sa table, ipa-plug in lang natin sa may So nakuha natin sa may formula, which is CL is equals to the X bar, adding and subtracting Z multiplied by S squared of N. 95% confidence interval is equals to the sample mean, which is 127.3, and adding or subtracting the critical value of 95% confidence interval, which is 1.96, multiplying the standard deviation, which is 19, and over square root of N, which is 3534. By calculating the right side, we have the value of 0.63. By subtracting 127.3 to 0.63, we have the value of 126.7, and by adding, we have the value of 127.9. In conclusion, a point estimate for the true mean systolic blood pressure in the population is 127.3. We are 95% confident that the true mean is between 126.7 and 127.9. The margin of error is very small here because of the large sample size. So that ends our discussion in chapter 7. Thank you.